Hi there! Sometimes I have to design and build something not for my own pleasure, but to make my wife happy. She is a physics and chemistry teacher at a local high school, and she is also the manager of the Science Olympiad team of that school. This time, she asked me to provide some cheap multimeter that the students could use for their experiments in physics, but that can also be used for some of the competitions in the Science Olympiads. And so, here I am, designing and building for the team 12 of these devices that I have called Breadboard Mini-Meters, which are capable of measuring up to 100 volts and 1 amp, and cost less than $10 each. Here are some pictures of all the components I used to build one of these devices. I found very cheap voltmeters on Amazon that are capable of measuring up to 100 volts using a power supply anywhere between 4 and 30 volts. I can buy 5 of them for just $11, and that is the costlier component in my project. Since these voltmeters need less than 20 mA to work correctly, I thought I could use a 9 volts battery as a power supply, which should last several hours. A power switch will take care of disconnecting the power when the battery is not in use, and for that I opted for a mini rocker switch, also bought on Amazon. I got 15 of them for just $7. Since I wanted to measure also currents, and since the voltmeter is capable of measuring tens of volts, I thought I could put a 1 ohm resistor in parallel with the probes and measure the current that goes to the resistor just by measuring the voltage across the resistor itself. The resistor could be attached and removed from the probes with a simple SPST switch, and with this solution, the current reading will have a minimal resolution of 0.1 amps. It's not much for a regular multimeter, but for something this cheap I think it's enough. In the future, I could design a new meter with a rotary switch capable of selecting different resistors for different current sensitivities, but for now this will have to do. I'm going to put in the description below the link to the Amazon page where they sell the voltmeter, for your convenience. For those who are interested, I'll also publish on my site eleneasy.com the files to 3D print the box. The link, again, is in the description below. And here is the schematic, very simple as you can see. The voltmeter is powered by a 9 volt battery to the rocker switch. The black wire goes to the negative of the battery, and the red wire goes to the positive through the switch. The voltage is then measured between the black and the yellow wires of the voltmeter. The other switch, marked with the letters V and A, is the one that inserts the 1 ohm resistor in parallel with the probes. The resistor should be capable of handling 1 watt, which is the power that will be dissipated when measuring 1 amp. When the switch is open, the device will measure volts. When the switch is closed, the resistor is connected in parallel with the probes and the device measures currents. Also, the assembly is very easy. I started installing the voltmeter in the case so I could easily keep it flush with the front panel while applying a few drops of glue from the inside. Then, the rocker switch and the other switch can be secured on the case panel. I made the probes out of a couple of made breadboard jumpers, which come out from the hole in the right side of the panel under the rocker switch. This way, it is easy to take measurements on a breadboard just by inserting the 2 jumpers in it. It just becomes a matter of connecting all the wires at that point. Once everything was in place, I tested the device by connecting it to a variable power supply to measure the volts. Then I did the same, but with the power supply set as current generator to test the ammeter capability. Since everything worked fine, I can now build all the other devices that my wife requested. I'll have to make a total of 12 of them. Oh well. Thank you for watching this video, and please give it a thumb up, which will greatly help improving the visibility of this video, so others can enjoy it too. Once again, don't forget to subscribe if you haven't done so already. I will greatly appreciate that since it helps a lot the channel. Also, a small monetary contribution will help in making more better videos for your enjoyment. Details are in the description below. See you on the next video, and as usual, happy experiments!